Okay, so if you guys remember that early series that we talked about, those prefixes, so the math, the ash, the probe, you guys remember those? Okay, so now those represent the number of carbons, right? You guys recall that it represents the number of carbons. So like bute has 4 carbons. Okay. Now if you also take a look at the physical state, as we add more and more carbons, we start to change states. So in the beginning, we have the first 4 are gases. The next one becomes a liquid. And part of that is because these compounds start to physically interact with each other. So they'll physically contact each other better. Where in the case of the ones that are shorter,
Do you have this one? Anymore? I don't have that back.
let me bring it up.
Okay, thank you.
And so the smaller ones, they're not getting enough overlap to cause that physical interaction, right? So there's not enough overlap between the chains to interact with each other. So when we get bigger, you could have a chain of pentane, one pentane interact with the other pentane, and they're going to have that physical interaction to cause them to change their state. So they won't be gases because they're bigger, essentially. And the bigger the chain gets, right, the more interactions that you're going to have. Okay. Yes. You need a copy of this one as well too. So I will have to. I'll send one of you guys over there. Yeah. Same thing. Where the printer is. Okay. So. Yeah. I'll get it for you in a second.
Thank you so much.
So, but the key is that these guys, the bigger they get, the more interactions that you have. So the smaller that they are, you're going to have less interactions. This is going to be something to know later on when you guys decide that you need organic chemistry, or when you start thinking about some of the other things. So if you guys take for instance, lard. You guys are familiar with lard? You guys use it. What state is lard in?
Solid.
It's a solid. So at room temperature, it's a solid, right? So lard is a perfect example because it has really, really long chains. Right? And because it has really, really long chains and they're interacting with each other, right? There, it's going to be a solid state. Now, we also have oils that also have very, very long chains. So the distinction between those oils and the lard is the state that they're in. So lard is typically saturated. Unsaturated. Unsaturated. I have to look. I keep forgetting it. One is saturated, one is unsaturated. Okay. So, and that also starts to play a state. So when we talk about saturated and unsaturated, saturation is just basically means that it's covered with hydrogen, so that there are no double bonds, there are no triple bonds. It's all single bonds. And so you know that the alkenes and alkynes, those are double bonds, triple bonds. So it has no alkenes and alkynes. Well, okay. I need that sometimes. Okay, so these guys are alkenes, these guys are alkynes. This here is what we call a common name. Okay, so we know the IU pack. And that's what you guys need to know from here on out, primarily because we went from the point where we're using common names to start using the IU pack. But they do still have common names. If you get one of these older professors, they're really stuck with those common names. They don't want to give them up. So occasionally you will still get a person that uses it. So you need to be familiar with it as well. So you'll notice that this one says ethylene, right? And so we know what the IU pack name for these are. Carbons. So what is the prefix for two carbons?
F.
F. Okay, so we know that it's F. And then it's a double bond. So what is the ending that we would use? So it would be called FE. Okay, so that would be the IUPAC nomenclature for this. Okay, so this one, again, it has two carbons.
Slide 33. They just went back.
So try to decide. Okay. Page 4. Okay, so two carbons, again, the prefix is,
Yeah,
and then it's a triple bond.
I.
Fi. Okay, so that again would be the IUPAC. Now we don't have to put locations because there's only two carbons, right? If there were more than two carbons, we know that there would have to be locations. Okay. Is it all coming back? I know we went on break and then you guys are like, exactly. So, okay. So let's see if you guys can remember. You guys remember you remember skeletal structures? Let me show you what they are. Okay, gotta remember that. Okay, so remember each and represents a carbon. So if we're going to name this guy, we have to count the total number of carbons. So this would be 1, this would be 2, this is 3, 4, 5 carbons. Okay. Now also we can count from either side. So we can you see the pink that we have right. So I can also count from the other direction. That's 1, that's 2, that's 3, that's 4, that's 5. Now, the way that we decide which directions that we're going to count for, again, is based upon where our structure is located at. So here we have, this represents about 5. Right? This represents 5 carbon. So if I have 5 carbon, what would be the prefix for 5 carbon? Pent. Okay, so we know that the prefix is going to be pent, PN. Okay. Now, is there a double bond? So we have a double bond. Double bond is going to be located either at the 2 or at the 4. You're always going to choose the one that has the lowest number. So it starts where it starts at the 2. So we want to make sure that we put a 2. And then the prefix for, the suffix for a double bond. Okay, so it's 2-pentene. Okay. So if you could have said it was, I guess that was 2, so the next number would be 3. So if you said 3-pentene, that would be incorrect because it's not the lowest number. Okay. So you guys see how to do that? Not a problem. Okay. So now that we have more people trickling in, I'm gonna run and get the papers. What I'm gonna do is I'm gonna put about 5 of them up there. Since you guys, we've gone over it. We're gonna see how well you guys remember. Okay, you guys ready? Okay, so I'm gonna go ahead and erase this one. Everybody got this one down? You got it down? Take the picture. You can see it on the exam. Okay, you guys ready? So let's go. And if you guys don't mind informing everybody else who came in late about what's happening, so that they make sure that they show up next week.
You said Monday, the 24th for the presentation.
And then what else is happening?
11 o'clock.
That's right, coordinated, 11 o'clock. Yep. Not coordinated, it's curriculum. Right inside curriculum. Yes. Many friends that are taking physical therapy, anything that needs physics, that needs chemistry, that needs biology, yeah.
To get more physics classes?
It's to get them to be offered consistently. Like, so
Oh,
this is
consistently.
the first time, so this is the first year that we had classes. I worked on all of those
Oh,
classes.
here at Kalinga or Lamar?
Here at,
Oh, okay. Kalinga doesn't have a lot of.
look at this, yes, Korea doesn't have very much, right?
Yeah.
And then, and often what happens is that they'll decide that they're gonna offer them last minute. And then no students enroll because nobody knows about it. And then they'll cancel.
Oh, and then they'll
Because-
cancel them.
Oh, yeah.
Offer this.
Because, no, we have teachers that teach. The problem is that they don't offer them because they believe that there are no STEM majors. So there are no bio majors, there are no chem majors, there are no physics
That's so
majors. there
weird.
are no-
Everyone wants to go into healthcare, like.
And-
classes.
Yes, but they don't understand that. And I keep explaining to them, this is part of the curriculum that they take. But they look at it from one perspective, and that's it. And it's about butts in seats. And so since COVID, we've been having a hard time getting butts in seats. And so the first thing that they want to cut are classes. They're hard. No kids here in this area are smart enough to take. And that was a
They
statement
said
that
that?
somebody had said. I won't mention it. It pisses me off.
Whoa, that's weird.
And I.
They're basically
live-
calling us dumb.
Yes, I didn't want
I
to-
get it.
They think because we're like in small towns that we're dumb. They make
They
it seem like we're not ever gonna.
So, do they start with like STEM classes and then start dropping from there? I like triangles.
In terms of, they usually start with low enrolled, and our classes are typically lower enrolled than some of the other classes. There have been other classes that they've offered that there'll be 2 people in there, and they'll run those classes, but they'll drop their classes. We'll have 10. They'll drop.
First one example.
So there was child development, public child development courses, where there were literally 2 people in the class, and they ran those classes because it's a program that I have my opinion. It's only an opinion. You know, I feel that there are certain people who make decisions because of population in the community. They feel that there are more people that would be apt to go into childcare in this community than to go into being a doctor. And unfortunately, that is some of the mentality that you're gonna have to do. small community, it's a rural community. They don't think you guys want it. They think you guys want to be ag, a lot of ag, which is cool. Ag is fine, you know, but not everybody wants to go into ag, right? Some of you guys want to be physical therapists. Some of you guys want to be doctors. Some of you guys want to be engineers, right? And so the thing is that they need to hear that because they have a preconceived notion of what this community is capable of. So, and it's been one of the things that we've been battling. You know,
So like if you do the Zoom, I think more people will show up.
yeah, well, I'm gonna do both, and so, but it's better if they see you guys in person, because, yeah, if you're available, you should come. If you're, you should come, and you should also let them know the difficulties that you guys have had in classes.
Well, yeah, we're talking from the war.
Yep.
Yeah, like that's ridiculous because the only chemistry classes they offer are like 9 in the morning.
Yeah.
Like, how am I supposed to make that work?
And then I've been the one that's been pushing because they wanted to do the same thing here. They want to offer them like midday, lunchtime, you know, and stuff like that. And I'm like, you know, that's not practical, but people actually work, you know, just like, believe it. These people are thinking about changing their lives. They have jobs already. They need the opportunity. And so we have issues with scheduling consistent. We have issues with, you know, so this has been an ongoing issue. Right? You know, and so it's been one of the fights that I've been fighting since I've been.
That's like, I think there's only like one physics class they're offering over there. I was like, I had to make sure I got into it.
Yeah.
Yeah, I was telling you at the beginning of class, I had to pay out of pocket for physics class and my online school, so I could get into the class. Yeah, because the seating is very limited. It's like 15 people. No, I
And they
never
were
take
having
it
out of
every
state
physics.
Yeah, we didn't start offering, this is the first year that we've offered physics. And it was 2B, so it's not.
Yeah, and you can't.
The out of state.
That you probably are going to be able to get into.
So just show them
And I need
to
to
like
take
see.
physics this semester.
Hopefully.
How much wood is? I was like, are you taking physics right now? I just finished it last year. Really? How did you pass it? Yeah, me. Oh, passed it? Yeah. It was, I mean, I took it at every riddle though, so it's like probably a little different than what you'd see here. It was kind of like a lab. I had online like simulation labs. It was all online. But I had to do like lab before.
But you did this class and that class at the same time.
Yeah, and statistics and statistics and information security.
Damn.
Yeah, that's like I dropped 3 pounds. This was like 3 part classes. I also.
You're a little- that's okay.
Yeah, I just wanted to-
You should have told me your age. I really thought you were. I thought you were
I
like
can't
her
take
age,
pictures on Tuesday. I have a job.
Oh.
Way better. So I was online. I ended up taking good. Okay.
I do too. That's all I do is play baseball.
Oh, that's probably why.
Should I do a thing for that?
They're all accredited and they gave me like $1,000 coaches about me asking for it. Wait, like where? And riddle.
In
California? No, it's all.
And where they located? Or is it just strictly online? Like,
They're in Florida, but you can do what you want to do.
oh, we get paid for it, so now.
Yeah, but they give me $1,000 coaches covered all of my like, class.
What, how do you qualify for this?
Have to have like, if you get money from FAFSA, you're all like. Yeah, called the United States earlier for my application, like, if
Oh,
you guys
wow.
are doing well here, you'll probably get it. Like,
No way.
Yeah.
It's like 9 right now.
I have a 3.0 and like have a machine.
No way. That's good to know. Yeah, there's just some investments in it.
Ew, but like, I mean, some Yes. people,
Okay.
like, if you can't get into class, So, you need to take it.
Yeah,
Like,
like, I really.
that's the first one, that's all.
Which one?
Okay, so the triple bond,
Yeah.
they count as
Where are you going?
this counts as one.
Oh,
So
that
that
counts
makes
as
it
a
a
one?
point.
That's
Yeah.
a one.
I'm already in Navy.
So,
Are you working full time?
Okay, but you don't count this up.
You do
Yeah.
5. So you see 1, 2, 3, 4. They count as 10. So they count that.
So these two count as just one, or does it go 1, 2, 3, 4, 5?
No, they just count as 1. So it's just a triple. Yeah, you missed this one. The one on the not the hardest one.
Okay.
We'll show it up. We'll show it up probably.
No.
So I go.
I was doing everything, she doesn't show up. She missed all the unemployment.
Oh, I used to give a big step.
It's a great shit, though. He says that.
Oh, what's your class right now? Oh, shit. When you start, no, when you start in the military? So you started fresh at 18?
Yeah.
I started a lot. So I know like. Yeah, more than military.
I would like.
Reading the subtitles for the.
That's what I'm trying to do right now. Wait, you want to leave the pilot? Yes.
So
Dude, that's
so
so
long.
cool.
Yeah.
You want to be true for them to pilot?
Yeah, but like a pilot for like an airplane or?
Yeah.
So
Wait,
you
wait,
wanna
do you
go,
want
like,
to do
yeah,
Eagles or do you want to do like pilot?
So it's
Wait, you have to, you just go out and fight? You have to be a
Yes.
fighter pilot to be a
So the first,
Yeah, and.
the first one,
So
was
she
like,
like.
oh, maybe a tank.
I have a tank.
Yeah,
Oh,
but
no.
it's just a fighter.
How do we do the ending?
Oh, they have to like.
Have you seen Top Gun? No, it's fine.
Isn't that seven?
So.
Oh.
I'm talking about the second. Technically the second one. I put it as
Oh,
the first
7
one.
time. Nine is 3.
Have you been in
Okay.
this situation
It's
or the
2.
relationship?
8. If it ends with 8,
Oh,
then
yeah.
it's single. If it ends with E, it's double
Really?
bonds. And if
It
it ends with I, it's triple
For more
bonds. You can have both
Yeah, but you can't just go and do
double
it.
and
Student pilot.
Oh, because in San Diego they have that.
Both?
And there's.
Wow, I just could do it because my mom was working there and with the pilots and stuff. But my dad, he was a manager of like the police
and the
station for
triple.
Eagles, and he just handed the job off to someone else in Maryland now. But yeah, that's really cool.
So this one has a
Yeah, he's
double
still
bond,
with
double
me,
bond,
so I
right?
don't get any
Start
perks,
at 1,
you
2,
know, like.
3, 4,
you know,
5.
I mean,
So it's gonna be on and then it's gonna be
Here's the
4.
number starts.
Like,
And
anyone
then
can
6
get
for
any
the,
perks, right? You have
what's
to
it called,
complete
double
like-
bond.
Oh, yeah.
So, and then ending with
Yeah, you need like a spouse.
Well, what are the
Yeah.
things you like?
And then you're gonna have 1 with I.
Yeah,
like,
exactly.
had to do the like 2 years.
He goes over this. Yeah, he goes, hopefully he goes over
Honestly,
this.
that was one of my process when I missed out. I was like, you know, I'm gonna have to go over there. I hope no one
Yeah.
shit.
Damn.
Yeah,
What?
Like,
That's amazing.
when he was
Yeah, you know, right? That's the we're, I was the oldest that I don't see.
True.
Yeah, you.
Damn, that must have been nerve
So you gotta do it.
No, they will and they pay for housing, for food, so you have like your license.
It depends what branch. I know the army provides.
You know,
classes.
but-
Oh, yeah, she.
Yeah,
She doesn't show up for no Thursday,
want
Wednesday.
to work healthcare and then not
Thursday.
just healthcare. I met a lot of
Wednesday,
like,
my bad, Wednesday.
because I work with patients who were like from the Navy or the
Yeah,
base,
for
and
one or
I
two.
kind of have a hard time like transferring healthcare skills out to the Navy because they don't do any like schooling or certificates or anything. They just kind of are like, well, since you're in the military, we're gonna let you do this stuff with patients.
Like you know how to do it, but you get certified.
But yeah, you don't need to certification.
So like say you like are
If you're drawing
base-
blood shit every day.
She did that
you
multiple
know.
times.
Yeah, you get
Okay,
certified
so
state.
it's gonna be,
But there's
the
a lot
same
that
thing,
get out
like,
of the
uh-huh.
firefighters, right?
and
So you
basically,
put the prefix for.
Yeah.
So for
cause you
This
can,
one?
no, you can write it like this.
Oh, my cousin is a tree. No, no, so. Yeah, no.
You can write it like that, it could be the same thing.
Okay, he
Yeah,
gotta
so
go
that's why
to
like,
classes for sure for this one.
Oh.
Yeah, he came, he's only his term, he went to
The
South
double,
Africa.
2, 4, and then
Okay.
Yup.
I think,
Your wife is not what you're supposed
if I'm wrong.
Honestly, we were on audio
He skipped some classes, he's supposed to go back.
So, like, let's say this one,
He didn't accept
he
his
had
classes, so he did classes.
1,
Right now, it's teaching
2,
the transition, like.
double bond, right, and then triple bond, right?
Oh.
And it was 7, so it's stepped up, and then 4 is where it's
Sure,
at.
she's starting to hurry up.
Okay, so I'm getting out. Done with my.
And then
contract, I'm getting out.
1,
I have 70 out.
Or where the double
So you're
bond
not-
Yeah.
Yeah, I'm doing more.
Okay,
I legit-
so you're not reserved then, no?
No, I'm not.
That's what I thought.
So I'm getting out for 7 days. Going to college.
Yeah,
Bro, you didn't show up.
Wait, I don't want to do this to myself.
Okay.
No, no, don't worry.
She's
Maybe should have, I think, something else.
I'll be
Who the other copy?
Yeah. I'll be from that.
So you're from the Moore, we got based in the.
Yeah, I'm
Thank
absent.
you.
We're really good too.
No way, that's so
I
crazy.
Yeah.
That is so crazy.
I live with my mom.
And then
It was the last.
I should have based you.
No, I live out now.
What the heck?
Yeah, you, like, once you get E5, you moved out.
Oh, it's right, break.
Okay,
The first one.
so let's look at this very top one. What's the name? I'm talking about the one that's colored.
Oh,
on the side. I can't say green because, okay, so how many points do we have? 1, 2, 3, 4, so it would be called butane. Butane.
So are
I like that, butane. Butane.
So are the hydrogens just like why?
Yes,
Okay.
and it's saturated because it's all double bonds. I
Okay.
mean, all single bonds, right? So it's all single bonds, so it'd be saturated, so that basically means it will be filled with as many hydrogens that are needed. Okay, and then this one here. Is it heptane?
Yeah.
Heptine.
Heptine. Heptine. Okay, so let's count them. So that's 1. Doesn't matter in some cases, but 1, 2, 3, 4, 5, 6, 7. And then it would be heptine, but is there something else that we need to prepare? Where's it located? Where's the double bond starting at? Okay, so 2 heptine. Because the double bond starts at, the triple bond starts at 2. Triple bond, the C represents the triple bond, so that's why we have to count our carbons to know where that structure is starting. That's right. And it's triple bond. If there are 2, it'll be double bond. Okay, so this one,
2, 4 heptene.
2, 4. Are you sure? Sure there's not anything missing?
No.
Okay, so we didn't talk about it today, but the last time we got together, we talked about the Greek prefix. What is the Greek prefix for 2? Di. Okay, so this guy would be called heptadiene. Okay, so it'll be 2, 4 heptadiene.
I knew it.
Okay, so the reason why counting, we're going to count from this side because our closest double bond is from this side. That's 2, that's 3, that's 4, that's 5, that's 6, and that's 7. Okay, so we have a double bond at the second, we have a double bond at the fourth, so that's where that 2, 4 comes from. The fact that there are 2 double bonds, that's letting us know. That's why we use the die. And we're letting us know that it's 2 double bonds that we have. Okay. White, you have a question?
Oh, no.
You sure? Got it? Okay. So what about the next one? Another hept, okay. Hept plate. So that's 1, 2, 3. So the third carbon that we start on a double bond. You can see the way it goes. 1, 2, 3, 4, or 1, 2, 3. Hept, E. Okay. Now I'm addicted to hept there. Okay, and this last one for the gold. Hex. You said hex. Let's count the carbons. Okay. Which side should I start counting? Or the left?
Yeah.
But isn't that the
Oh,
one?
5. 5? No, it's not 6.
Okay, let's start counting from this side. That's 1. We have a triple bond here. Right? So that's 1. That's 2.
Oh, I wasn't counting.
That's
Yeah.
3. That's 4. That's 5. That's 6. That's 7. That's 8.
That's 9, correct?
That's 9. You said 9?
Say 9?
Yeah. You gotta say it louder sometimes, because I can hear you say 9.
No, that's good.
I heard hex. I heard, I heard 5. I heard, So we have 9. So what is the prefix for 9?
No name.
That's right. Known. Known. Okay, so we have known. Okay. And where are the triple bonds located at? We have 1 at the 1. Okay. And
Say 7 or 5.
that's
Oh,
7.
7, right?
Yeah. Sorry, that's a 7. 7. And then it should end with what?
Dying.
Die. Dying.
Dying.
Dying. No, not dying. That's right. Dying. Dying. Okay. You guys got that, right? Okay, so you guys ready to move forward? There's a lot of good job. Okay, so guys, let's go to the next one. Okay, so the next thing that I want to talk to you guys about, we've talked about it briefly. We've talked about isomers. So an isomer is compounds that have the same chemical formula, but they have different structures. So here is an example of an isomer. So, or isomers. So if we look at the chemical formula, it's C3H6BrCl. Okay, so we have 3 carbons here. We have a Br located here. We have a Cl located here. Okay. We have a case where we have Br here and a Cl on the other side. And then we have a case where we have Br and Cl directly across from each other. So those are 3 independent structures. They're going to behave differently. They're going to react differently. Okay. So we also need to talk about what we call the primary, the secondary, and tertiary carbons. Okay. So this here, your primary carbons are going to be those first carbons. Those are considered your primary carbon. those inner carbons are going to be your secondary carbons. And your tertiary carbons are going to be carbons that are going to be coming off of those. Okay. And we'll talk a little bit about that. Not too much at this level. We just want to introduce organic structures. Okay. But the key is that you need to be able to identify isomers, basically things that chemically, their chemical formulas are exactly the same, but they have different structures. Can you guys see how they're different in their structure? It's clear. Okay, we've already talked about how to name. You always have to identify the longest carbon chain. Then you use that to sit there and get our prefix. So there are going to be cases where we have chains coming off our primary chain. So these are called branch groups. Okay. So here is an example of a branch group. So the first thing that you want to do is to identify your longest carbon chain. So if we go through and identify our longest carbon chain, we have 1, 2, 3, 4, 5, 6, or we could go the other direction. 1, 2, 3, 4, 5, 6. So then we recognize that we want to use the lowest number. So if we go with the pink numbers, the ones on top, okay, go with the ones on top, you have something coming off the fourth carbon, right? If you go with the ones from the bottom over here, the green numbers, right? So then we have something coming off the 3. So our lowest number is going to be a 3, right? It's a 6 carbon chain. So if it's a 6 carbon chain, the prefix for 6 is what?
X.
X. Okay. They're all single bonds, so it's XA, right? And since there's 1 carbon coming off of it, we call this guy methyl. So we just add a YN to that methyl. If there are 2 carbons coming off of it, we'd call it ethyl. If there are 3, we'd call it propyl. Okay. Now here's an example where we have multiple carbons coming off of our longest chain. We have 1, 2, 3, 4, 5 carbons. Going the other way, so that's 1, 2, 3, 4, 5 carbons. We're going to use, again, the smallest numbers. So that's going to be 2, 3 instead of 3, 4. And this is, it's 5. So what is the prefix for 5? Pent. And then you have a single carbon coming off of this chain, and you have a single carbon coming off of this chain. So again, for 1 carbon, what is the prefix for 1 carbon? Meth, that's right. So then we use methyl, right? And since there's 2 of them, we go dimethyl. So it's 2, 3, dimethyl. Okay. Are you with me? Okay, so we're going to test this out. Okay, so what is the first thing that we want to do? We want to count. We need to find the longest carbon chain. So we start here. That's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7. If I start here, that's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7. So I can either start here or I can start here. Okay. Okay, so we have a 7 as our longest carbon chain. So what is the prefix for 7? Okay. 7. Okay. Are there any double bonds? No double bonds. So what is my image? Push it back. Pain. Okay. Okay, now if we take a look, we have a single carbon coming out of here, and this one would be 1, 2 carbons coming out of here. Okay, so what is the prefix for a single? Beth? The way I remember it is meth users always use 1. Okay, and then 2. Back. Okay, so since these are side chains, we put YL at the end of them, and you do it alphabetically. So alphabetically, who comes first, E or M? E. E. So the E would come first, so we would say it would be 3 ethyl space 2 methyl M. So there was a question earlier. I'll get back. Take it back a step. So when you're counting, you can count from either way. You always want to get the lowest numbers possible. So we can always count from either end, but we always want to try to get the lowest number possible. We also want to try to get the longest chain. We want to encompass the longest chain possible. Okay. So you guys can see longest chain. Want to try one more? Yeah. Or do you guys feel you got this? Try one more. More.
Right, no matter like what side we start on, long as try to do the longest.
You want to get the longest chain, and you also want to get the lowest numbers. Okay. So I think like you always want to be first place. You don't want to be last place, right? So you always want to try to get the smallest numbers. Okay. Okay, so where should we start counting?
Top of it.
This one here.
No,
This one right here. Yeah. Okay, so we start here. That'll be 1. That's 2. That's 3. That's 4. That's 5. That's 6. Where should we go after the 6th one?
Up.
Go down.
Up.
You say up. Okay, so if we go up, that's 7. That's 8. That's 9.
But you should go shortest one, so go down.
We want we want the
The
longest.
I mean, the longest one, but like
Okay,
shortest number, right?
yeah, we want, but shortest number where something is located on.
Okay.
Okay, so if we go down, that's 7. That's 8. That's 9. That's 10. So this would be a long chain, right? but is that the longest? So if I start here, that'll be 1, that's 2, that's 3. You guys see that?
That's shortest chain, right?
So, but we want the longest chain, but we want the smallest numbers. Okay, so that's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8, 9, 10, 11. Okay, so that means that we have something on the 4 and we have something on the 7. Okay. If we went the other way around, that would be 1, 2, 3, 4, 5. So this would, the red numbers give us the smallest number where things are located. Okay. So here we have something here, right? And then on the 7, we have something. Okay. So we have this one located on the 4, and we have this one located on the 7. So first, let's do the last part of it, the name. So longest chain's name is deck. Is it double bonds, single bonds, double bonds, single bonds, triple bonds? Decade, okay. And then we have something located on the 4. It has 2 carbons. It has 2 carbons. And then ethyl. So we put 4 ethyl. Okay, and then we have 1, 2, 3 carbons on the 7 chain. So what is the prefix for 3? Not that prefix. We're talking about carbons. What's that? Prop. Prop. So that's propyl. Okay, and where is this? On the 7? So it's 4 ethyl, 7 propyl, and decade. It's for the red numbers. Because the longest chain is 11, not the 10. Okay, questions? Concerns? Cash money. Okay. Let's see. Arnell, do you guys have any questions? No questions? Okay. Or I should say online. Are there any questions? No questions. Okay. We'll move forward then. Yes.
You doing online classes, is that having to do with like what we were talking about? Like more classes like show more interest or?
Yeah, so part of the reasons that I'm doing online classes is because I teach at Hartnell as well. And theirs is it's a hybrid, and it's a way of me testing out the hybrid part of it. So I do the recordings and I post those recordings and I look at how many students actually watch it. Because in the fall for 2A, they're going to actually put the yeah, I believe it is, but it was a way so that we can get some of the upper division classes off. So I'm going to try to use it as a bargaining. Yeah, a compromise. So. Yeah, and the labs are a lot harder to do online. You know, they're going to get kits delivered to them. They're going to be doing it from their house. So it's always So much.
That sounds dangerous.
So
Just kidding.
can you guys hear me? Is it better, Dulce? Okay, thank you. Okay, so when we're talking about these structures, so we got to understand these structures are going to be flexible. That's one thing that we want to say. So since they're going to be able to rotate and stuff like that, that's also going to play a part in their structure. So we need to kind of be aware of that. So if you guys take a look, it says we have 3 X's here. So these are considered to be geometrically equal. So geometrically equal. So you guys remember that because we talked about that concept. So we have essentially 4 attachments here. 1, 2, 3, 4. So since there's 4 attachments, that's going to be 10. Basically, they're all 109.5 away from each other. Okay. And so the 3 Y positions are going to also be equal, and the 3 Z positions are also going to be equal. So they're all going to be located. These guys are going to be 109.5 degrees away from each other. Looking at this errata, all of these 4 attachments are going to be 109.5 degrees away from each other. So they're all going to be located. And we got to remember that these guys are able to have rotations. They're going to get an orientation that is going to be stabler than others. So they're going to try to find an orientation that fits them well. Okay, so sometimes we have other structures other than the carbons and the hydrogens attached to our carbon chains, right? So here is an example that we have. These are called halides added on. So we have bromine, chlorine in this situation. So we have the Cl and the Br that's going to be attached. So instead of hydrogens there, they're going to have Cl and Br there. These technically already have hydrogens attached to them. They're just that they have hydrogens there. So in this case, I'm going to draw out the hydrogens to kind of help you visualize it. So this one would have a hydrogen here. This one would have a hydrogen here. Here. Those are going to be all of our hydrogen. One at the end here. Okay. So again, nomenclature is going to be exactly the same way. You want to find the longest carbon chain. That's 1, 2, 3, 4, 5. So we use pent, then ane, since they're all single bonds. Now we have bromine and chlorine attached. So instead of using bromine, we use bromo, and we use chloro. We count to give us the lowest numbers, where those bromos and those chloros are located at. Okay, so that's 1, 2, 3, 4, 5. So we have 2 chloro, 3 bromo. And again, it's done alphabetically. B is before C, so we're going to put the bromo first. Okay. Okay. Now there is a hierarchy to this process. Halides are at the bottom of the hierarchy, right? And that's part of the reason why they get put in front. The carbon chains are also like side chains, the branching chains. Those are also lower on the hierarchy, so that's why they also get put in front. So things that are lower on the hierarchy are going to be put in front. The things that are higher on the hierarchy are going to get the prefix. I mean, the suffix, the last name. Okay. So, okay, this is gonna sound very racist, I mean sexist, not racist, but very sexist. So in the US, when a woman marries a man, what happens? She takes his last name. So, because the man is more important. Right? Okay. What? Okay, so it's a patriarchal society. This is typically what's done, right? So here, the one that has the highest hierarchy gets to have the last name. So in this case, the single bond carbon is more important than the bromine and chlorine, so we get the amine at the end. Now we're going to start talking about other groups. So one I would love to start talking about is alcohols. You guys are familiar with the alcohols, right? Not the stuff you drink all the time. We'll be talking about that in a little bit. Okay. Okay, so alcohols. The prefix that you're going to use for alcohols. Alcohols have a higher priority than the enes, the ines, and the anes. Ane is the lowest. The triple bond is the lowest. The ene, the ine, and the ene are equal. Then we have alls. Anybody have their periodic table, their packet? I think I gave you guys this. Get it back with me? Yeah. Make it another. Sorry. All right. So if you guys go to looks like this. Like that, just like that. Okay. You guys at home, I'll put it up. Have 15 different things. Okay. So you guys have this packet, this one here. Okay, you guys have this packet. This sheet, you guys have sheet in front of you. Okay, so in terms of priority, this is priority. So except the haloalkenes are actually behind the alkenes. So it would be in this order. You'd have your alkanes, the lowest, your alkenes, your alkynes. These guys are at the same level. And then we have our ethanols, our alcohols, and then we have our ethers. Okay. And then these guys are really below the others. So you guys take a look on the sheet. Look again. So we won't talk about these, but at the bottom of the page, you have your alkaline halides. those guys are at the bottom. Ethers are technically above, but sort of. Let me explain to you why. So ethers can go with the naming here. Let's see. Okay, so with ethers, you can use the oxy. So oxy just means oxygen. And you have your always the one that has the longest chain will get the ain part of it. The one that has the shorter chain will get the oxy added on to it. So this one is just methyl ether. That would be its common name. Its common name is more commonly used than the oxy. Or you would call this methyl oxymethane. So it's technically below it. However, if you use the methyl ether, it's above it. So that's why it's kind of located here in the other one. Okay. Now I'm going to go through and I'm going to teach you guys about the ethers, how to do the ethers, how to do the alcohols, and I'm going to teach you guys how to do amines, because you guys are going to encounter those more than you will encounter some peppers. So you got ketones and aldehydes. Then we got to get to some of these. So keep that sheet out because it's going to be important here while I explain this. Okay, so when we talk about, we're going to start off with the alcohols. That's one of the function groups. So these are called function groups. And so in the case of the alcohols are going to be adding OH to our carbon chain. Okay, so if we have 2 carbons, and then at the end we have OH, that OH makes it an alcohol. Okay, so 2 carbons, something that has 2 carbons in length, is the prefix is what? F. So we start off with our prefix F. Okay. So since they're only single bonds, we use the AN and then we use all at the end to let us know that we have an OH or hydroxy. So if I have 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5 carbons. And this last one is attached to that OH, so that is a carbon, it's just an OH. So then that guy would be called pentanone. Okay. So if I have So how many carbons do we have? Is it 6? That's 1, 2, 3, 4. And remember, this is an OH at the end. It's attached to an OH. Right? So this line goes right to the OH. So that's 4 carbons. So then four carbons would be you said bute. Okay. So we have a double bond, right? So then we're going to use EN and then all. Okay. So we have to say where the double bond is located at, because it could have been at the second carbon or the third carbon. The beauty is that the guy that's the most important, right? That's if it's at the end, you want to give it the lowest number. So rather than starting from 1, 2, 3, 4, we're going to start the other way. 1, 2, 3, 4. And we have to give us the location of the double bonds. There's 2 ways of doing it. You can do it with giving us the location of the double bond by putting it on the front. So it's on the first carbon. Starts on the first carbon. Okay, 1 butene. Or you can do it by putting it right next to the E. So you call it 1. All. Or you can do 1 bute. Because the OH is also on that first carbon. The easiest way of doing it is putting the number next to each of the functional groups. Okay. Got it? Okay, so let me see. Let's see. Now, this is called a primary carbon because it's on that first carbon. So the alcohol is on the primary carbon. It's on that first carbon, it's on the carbon on the ends. If it's on a carbon that's on the inner part, it's a secondary carbon. So then you have your functional group is on a secondary carbon. I'll give you an example of that. And then I'll show you how to work with that. Okay, so here's an example of them being on a secondary carbon. So your OH is on a center carbon. So the way you would do that, you'd also count to find the lowest number, longest carbon chain first. So what would be the longest carbon chain in this case? So here comes 3, 4, 5. And regardless in this case, regardless of where I started counting from, my functional group is on that middle carbon, right? So it's always on the 3 carbons. If I count from this side, it'll be 1, 2, 3. If I count from this side, it's 1, 2, 3. So then, in this case, this guy would be called, since it's a 5 carbon chain, what is going to be my prefix for 5? And then AN, since they're all single bonds, and then OL. So we call this 3, because we have to tell where the alcohol is located at. So it'll be 3 10 to the Okay. Questions? Or okay, so sometimes we have what we call cycloalkanes. Cycloalkanes just basically means that they close in on each other, so they form ring structures. Cycloalkanes are often responsible for a lot of the smells that we get. So you'll see something called like benzene or aromatic alkanes. Okay? So those guys are going to smell. So you guys are familiar with strawberry, how strawberry smells, right? So that's the reason why a strawberry smells the way it does, is because the chemical structure that's in strawberries that causes that smell. So we can make that synthetically in the lab. Or bananas. Like this smells. Anybody like the flavor of banana candy?
Yes, that's so
I
good.
love banana candy. What's wrong with you guys?
I like that.
You like banana? You don't like the candy?
Big difference.
It is
Yeah,
a
the
big candy.
Yeah.
It's so, I like the candy, but it's fruit.
Oh, I like the
So
I know it's
we
coffee.
know that the candy is totally synthetic, right? So the flavoring that's in there, that's also an aromatic flavor. The smell that it gives is also an aromatic smell. In the banana itself, the banana has a certain smell to it. Right? It's really sweet. The smell that it has, so that's also a ring structure. So a lot of the ring structures are going to be responsible for the smells that we have. Yeah. And we will call those guys aromatic alkanes or aromatic hydrocarbons. Okay, so cycloalkanes, again, it's going to work exactly the same way. Each tip represents a carbon. So this guy has 1, 2, 3, 4, 5, 6. So if it has 6, what would be the prefix for it? Okay. Yes, I did hear you, but you're talking under your breath again. So, but since it's a ring structure, we call it cyclohexane. Okay. So let's say we had this structure here. I know it's not even not in our nature. They want on TV. Okay, so how many carbons are there? 5. So then this guy would be called cyclohexane. Simple, right? I have blind, so I can see it. But I want you to take a look at the label on there. Okay, so if we have if we have stuff coming off of our carbon chain, or our carbon ring. So we want to try to get the lowest numbers. And here it doesn't matter where you start from. You just want to try to get the lowest numbers possible. So we can start counting from here, 1, 2, 3. Or we can start counting from here, 1, 2, 3. So here we have a single carbon coming off of here. We have a single carbon coming off of here. So we would call this guy 1,3-dimethyl cyclohexane. Okay, you guys got that? 1, 3. Okay, so let's see how well you guys got that. Because you guys look like you have it. Oh, somebody asked a good question. Sorry I didn't answer your question, Brenda. So let me go back to Brenda's question. Brenda asked, what happens if there are OHs on both ends? Okay, so let me put an example of that real quick. And we'll talk about how to do it with. So we have so if they're both at both ends, it's real simple. It doesn't matter where you start from. 1, 2, 3, 4, 5. But we know that we have 2 OHs, right? So, oops, sorry, that's wrong. 1, 2, 3, 4. This is the OH, right? 1, 2, 3, 4. Okay, so we have 2 OHs. So we have to say where they're located at. So where are they located at? You see that? Okay, so where are the OHs located at the top? Where? Where are the carbons? Where are they located at? Which carbon are they attached to? 1 and 4. So we're going to go 1 and 4. So we're going to go 1 and 4. And so how many carbons do we have? 4. So what is the prefix for 4? Bute. Okay. Is it all double bonds, single bonds, triple bonds? Single. So we're going to go A and butane. Okay. So it'll be butane. And then if there's 2, what is the prefix that we use for 2? Di. So diol. So it's 1,4 butane diol. Now, sometimes you say it written with E. In most cases, you say it without. So we go ahead and name this guy. This guy has how many? How many carbons in the ring? So that's 1, 2, 3, 4, 5, 6. Okay, so we have 6. So what is that prefix? X. So, and it's a ring structure, so then we should have what in front of it? Cyclo, and then X. Any double bonds? Double bonds, so. Okay, now the next part is, how many carbons do we have hanging off of it?
Altogether.
No, individually first. So we have,
Oh.
on this one right here, this is first one, it's 1, okay? And then this one here, we have how many? Okay, so since there's only 1 hanging off of it, we're gonna use the prefix of. Okay, and then we need to say its location. Now, when you're working with the location, you always want to get the one that seems the most complicated, the lowest number. So who is more complicated, 1 or 2? 2. So we want to give 2 the lowest number. So then in that case, we'll have 1 F, 1 F, 2 methyl. Cyclohexane. Okay. Not too bad. Okay, so I'm gonna see if we can make that. So piece together the puzzle. Okay. How many carbons? 4 carbons. So yeah, 1, 2, 3, 4. Okay, so that would be. Okay. Any double bonds? No double bonds. Is it a ring structure? This is not a ring structure. It's considered a ring structure because it closes in on itself, right? Even though it's a square, right? It's still a ring structure. Okay, so then should we use cyclo? Okay, and we have an OH, right? So what is that we use for an OH? Oh. Okay, and we have to say where that is located at. So you could just call it cyclobutanol, or you can tell me the location. It would just be one cyclo. Yes.
Wait, so for the OH, what we got to that? Is it just the NOL or?
It's OL. So for the alcohol, yeah, for OHs, that's just all OL. Okay. Now, because it is a higher priority than the ene, the ine, and the ion, ane, ene, and ion, we end with all. If there's something that has a higher priority than it gets put up in the front. I'll show you an example. They'll say, are you still, do you understand? Are you getting it? Okay, let's clear. Everybody got this down? Confident. Okay, So what we're gonna do is, we're gonna take a 10-minute break, potty break, and then I want you to, because you guys are dead. No, it isn't even Monday anymore, so it shouldn't be looking dead. So take a 10-minute break, we'll stretch your legs, come back, and then what we'll do, we'll start putting some things on the board, and we'll see how much of it you guys can actually. That's in fact. Yeah. If not, then we have.
I have 2 laps.
Oh.
Huh? I mean, if I can read my handwriting, I think I'll be able to.
Gas.
Wait, is this one we did?
Yeah.
Yesterday?
No.
Yes.
That's not the one. This is last week. This is what I have to finish. That one's
Just about that.
I think so. If
Huh?
And he was so prepared.
I would have. I'm so bad. For Henry.
Okay.
Oh, great.
This one, I think we didn't have one here.
Nobody wants to go to the bathroom. Nobody wants to stretch your leg. Now, if you guys start sleeping on me, I'm gonna throw something at you. Just no.
Oh my gosh, Michael.
They go through.
Is everybody back online?
Yeah.
Oh, I started it.
That's the one we did yesterday. Or yesterday, Monday. And a few months back.
So is that better? Is that better? Can you guys all see it?
I just like how small it is.
I'm just very recognized. It's like, my parents in the military.
Oh.
Yeah, exactly.
It's somebody, it's like,
Yeah, that means if you can find like.
So.
That's
I don't know.
what else?
One is five.
Okay.
8 hours.
Me too, but I'll
It's
say
okay.
that.
She has a, what's it called? A 2 day late.
Oh.
So, yeah, but the class actually.
That's a little.
I can't believe I got it.
That's what they're.
I don't know, I have a lot of stuff down.
Get over it.
I know, I was, my dad had like second half of the fly and I tried
Best.
Yeah.
Are you ready?
I don't get to this.
Are we ready? Okay. So where should we start counting it up? Okay.
Probably go into.
Yeah, but we want to try to count, try to give our most important guy the lowest number. Who is the most important? The OH. So next part. One.
Yes.
And if you have another structure that's coming up, so we want to try to give that another one. Okay, so then we should go this one. That's 2, 3, 4, that's 5, that's 6, that's 7, that's 8. So an 8 card ring structure. 8 carbon ring structure. So we got to have a cycle. Any double bonds? No double bonds. Okay. You just tell me where that the OH is located at. Right. Okay. And then we have bromo. So you said 3 bromo. Okay, 3 bromo, 1 cyclo octyl. Okay, B. Where should I start counting? That's this side or this side? Left or right? Right. Okay. So that's 1, 2, 3, 4, 5. That would give us our lowest number. We get something starting off with 2. If we started from the other side, it would start off at 3. Okay. So 6 carbon chain. Double bond or single, what's that? E. Okay, where's it located at?
2.
2. And what is this hanging off of this 4 carbon? 2 singles, right? So we have 2 singles. So since there's 2, we're going to be using a prefix. So di. And then if it's single, it should be M. Not and. It's a single carbon. Carbon. Not single bond. So this is just there are 2 individual carbons, 1 carbon. That There we go, diamond. Feel like I'm playing charades. Okay, and then they're both located where? Four. On the four. So it'll be 4, 4. We have to say where both of them are located. Yeah.
So, oh, the two.
So they're both
Two
coming off of
carbons.
this.
Got it.
Two carbon. This is carbon here, that's carbon there, right? Okay. Yeah. There's like one question. One question. Or maybe two. Might be two. Yeah, I can't remember. So
I'm
that's-
sure if I focus really hard on it.
Pay attention to the function. That's it. Okay, the next one. I said pay attention to the functional groups. That's gonna be important. And they're in your package, so there's no reason. You don't have to memorize it. They're provided. Okay, the next one. C. Where should I start counting from?
Okay, a question. Do you want the little extra story? I don't know, that's right. Do you want that to have a lower number or the bond to have a lower number?
So you want the bond to have a lower side.
Okay, so we start at
Chlorine is low on the. Okay, got 7 carbon chains. 7 carbons. Talk to me. Empty. Done. Anything else? Anything else that's on here?
I was like, I almost.
Yeah, see where it's located. Yeah, I get those.
Oh, the triple is that 3.
That's because that's our E, right? So
Right.
So when that's located.
3.
Two. Two. Okay. And then we have a CL coming off of the 6. So 6 chromo. 6 chromo. Or not chromo, fluoro. Fluoro. Chromo, bromo. Yeah, fluoro, fluoro. 6 fluoro. Okay. Last one. Got this one. Roll. Easy. I guess you say. That's the, we'll get to that part in a minute. Not there yet. So we're gonna start on the left-hand side counting. So we have 1, 2, 3, 4, 5, 6. 6 carbon chain.
X.
X. There's 2 of them. Die. Die all. Okay, and where are they located at? 2, 3. Okay. Good job, good job. I see progress. We talked about enes, we talked about the ides. This is just giving you a little more information, so you guys are very familiar with this. And so when we talk about unsaturated fats, so that basically means that they have double bonds or triple bonds. Okay. So I've talked to you guys about the rotation. So these guys are able to rotate. Now, when they're double bonded, they're not able to rotate. Right? They don't have that free rotation. They're single bonded, they're able to freely rotate. Okay. Aromatic hydrocarbons. So these guys, as I said, the ring structures are going to give you smell. Now, when you have the benzene ring, that is the father of the smell, right? So a lot of our aromatic hydrocarbons, they're going to have benzene rings involved with it. So benzene is alternating double bonds in a ring structure. Okay, if you guys take a look, you have a carbon, double bond, single bond, double bond, single bond, double bond, single bond. Okay, and so the way that we draw it to make it easy for us is that we make the skeletal structure with a circle in it. So that means that's the symbol for benzene. Okay, or alternating double bonds. Okay, so this is what it looks like. Really, this is how we draw it for simplicity. Okay. So you guys have been introduced to alphabetic, open chain, basically things that are not in a ring structure, right, that are not connected. So that was the alkanes, alkenes, and alkynes. You've been introduced to the alphabetic cyclic, which are just the cyclic alkanes. And now you've sort of introduced to the aromatic. Okay, so we've already talked about the hydroxyl groups. So you guys are familiar with the hydroxyl groups. The next thing that I want to talk to you guys about is the ether. Okay, so do you mind if I do it on the board rather than trying to write? I have a couple of questions. Okay. So I'm going to show you two ways that we're going to name ethers. One is called, as I said, is the common way, or which is more commonly used, and one is the IU type. Okay, so ether is oxygen in the center of hydrocarbon chains. Okay, so the way that we would go about naming it is counting and finding the longest carbon chain. So which one is longer? This looks like a crazy spider, right? So this one or this one? Press that. Okay. So then what we're going to do, we're going to count the carbons. 1, 2, 3, 4, 5. Then here. 1, 2, 3. Okay. So we take the one that has the longest chain. That's going to be the last name, and then we call it 5 carbon chain units. Okay, it's all super bonds. So we're going to say pentane. Okay, and then this guy has how many carbons? 3. 3. So we're going to say, what is the prefix for 3? Right. 3 carbons specified.
F or wait, no, prop.
Prop. So what we're gonna do is we're gonna say prop, and then since there's an oxygen, we're gonna say oxy. Propoxy. Oxycut. Okay, propoxy pentane. Okay. So what do you guys think oxycut? It has oxygen between 2. That's so. It does have the oxygen in. No, not cotton. Even though it sounds. Oh,
Yeah.
so there's E and E. So that E and E means what again?
2 double bonds.
It has 2 double bonds. So. And then this here is being used to define code, right? Meaning that there's something else on the other side. Okay. Pretty simple, not too bad. Let me give you another one. Second step. Two. 1, 2. So what would we need?
And
1, 2.
ethane.
And oxy.
And oxy. Said. And oxy.
Bunch of different shit.
No. Well,
So much time. A lot of substance. I think of oxygen. Super amount of substance. Just like take extra every now and then.
Okay, so now this here is the IUPAC way of making.
when it's written.
Now I'm going to tell you the way of making it common. This guy has 2, right? Okay. So we call this diethyl. This guy would be called, longest chain gets the last one, right? Or it's alphabetical. So we have propyl, P, and N. Which one goes first? So it's alphabetical. Propyl. Okay, so we call this N. Propyl. Propyl. We're going to be more worried about the IUPAC. If you can do both, that's great. Because sometimes this is what happens. Like I said, this is what you see most commonly. Right? Hardly ever see this. Right. Okay. Okay, so those would be ethers. Let's move forward. And then we'll do a test run.
I have a question.
I have that answer. Yes.
Why do we start from
Why do we start from?
like where the O is and not like? where from-
So because the O is the defining feature, it is the function of this case, right? So you started counting your numbers out from the O. So if there were structures that were coming off, this is always going to be that first current. Okay. Good question. Was that the same question you had?
Yeah, he's used to hear him just being up. He said it's super low.
Oh, okay.
Yeah, he barely heard him. I barely heard him. I was
Okay.
saying he had a question.
Oh, you were just saying he had a question.
Yeah.
Okay. I thought you said I had a question.
Gotcha.
He tries to be shy.
Speaking so loud. I miss you. You heard him.
Okay. Okay, so we talked about the hydroxyl function. We talked about or the alcohols, right? So that hydroxyl, right? That is going to be used when you have something that's more important than alcohol, right? So let me give you an example. Let me get to a problem first. So we talked about systems, talked about ethers, talked about alcohols, and then we'll give you an example. We're gonna actually skip part of this, talk about it sort of. So if you see up top, that isopropyl alcohol, isopropyl is a common name. I'm not gonna have you guys worry too much about it. N-propyl, again, is a common name. So these are common names for that same I acid. And so you guys use isopropyl alcohol at home, right? Alcohols, ethers. Okay. Our next ones are aldehydes and ketones. So the difference between the aldehyde and a ketone is aldehydes are going to have carbon double bonding to an O and then attached to a hydrogen and a hydrocarbon. That R represents a hydrocarbon, any hydrocarbon. Okay. Where a ketone is going to have the double bond attached to a carbon, and then you're going to have hydrocarbons on both sides. Let me give you an example. I guess I should turn it over to you. So okay, so this would be ketones. So the way that we name the ketone is that we want the longest name, the longest carbon chain, the longest. Enough said. 1, 2, 3, 4, 5. Okay. So we call this guy 3, 5 carbon chain. Let them know. That's right. That's right. It's going to answer the only. So we're saying where that double bond is located on that carbon chain. Okay. Now this is an aldehyde. So an aldehyde is going to end in AL. That's going to be its. So in this case, we count the carbons. 1, 2, 3, 4, 5 carbons. 5 carbons. That's up. Not high. That's up. Ah. So. Ah. What's that? Yes. So it's going to end in AL. Okay. So we know that that's different than no, right? Okay, that's it. And so you notice that we didn't have to say where it's located, right? Because it's always going to be on that first card or the outlet. Not for this one, there's not exceptions, but when you start putting them together, you have to know who's more important. Okay, and that's where your hierarchy is. It's paper here, it kind of, it's pretty good about the hierarchy. Pretty good about the hierarchy. You have ketones and your aldehydes are on those. Okay. Wait for the next one. Are you feeling comfortable with those? Do you want to do one more of each? Are you feeling good? Feeling good? One more? Okay. Chicken sandwich.
For Popeyes, KFC.
KFC. Somebody brought it to me. So
Hamburger does Popeyes. Popeyes is fire.
I like it.
Yeah, so good.
Papa's
Are you serious?
Oh, it's so good.
Kidding.
It is so good.
No, it's horrible.
What do you eat?
Chicken sandwiches there?
Spicy chicken sandwich?
Bro, I have everything.
I know, you know, like salty chicken or
Dude, it's all about keys,
one of
bro.
those table cloths?
Oh, this is good.
No, just like too much work.
Yes. I didn't give it a start.
Only because you guys are going to
Well, I should put it on. I'm seeing pain.
You guys ready?
Yes.
Okay, so first one.
X. 6.
Anything else?
Cycle.
Oh, wait, no, that's not how that works. That's.
Oh,
I had a brain. One.
Cycle hexamer.
It's consec.
I don't have to put them out.
Yeah, I was thinking.
You always
of the number, and I was like, no, there's two bonds.
If there was something else, then we would have.
Like, like,
You-
like
no,
how
it
it's in the
makes
first
sense.
example, it's at 3. So we put a 3.
Yeah, because here it's open, it could have also been
That's a good thing.
at the second square, right? So it could have been 2, or it would have been at the first. It would have been at the second.
Because it's a closed one. we don't-
That's right, you always start at the function, you always start at 1, if there's nothing else attached. And then if there is something else attached, you want to give the lowest number to the most important functions. So it's kind of like society, you know, rich people are more important than poor.
Right?
Supposedly, well, the way society works, it.
Oh, finally, I still understand.
It hurt. It hurts.
It hurt, but it's the truth. It's the truth. Okay,
Yeah, I go
so.
with you.
100%, but.
Okay, you ready? Next one. Five.
I got it the other way. Yeah. So why'd you come from the right then?
We're always gonna start at the double one.
Okay.
It is primary.
Okay.
And even if you count it from the other way, it's still.
Oh, I just didn't know. I didn't know what you said.
On 4, diet.
So, double one. Other than.
But that's what I was, I don't know if it's that though.
Excellent.
What I said.
Okay, and then what? And- What?
Excellent.
Right. OL or
L.
AL? X and out, that's right. X and out. X and out. Yep, X and out.
Oh,
And then are there any other structures on here?
You know, like another.
Yes.
What are they?
Would you?
Single,
There's no letter in what the
Single particles. So how do I handle that?
It's gonna be 4, 5,
4, 5.
die.
That's carbon.
So.
Met.
There you go.
As long as I know I'm right. As long as I know.
Good job. Good job. I love it when you guys get stuff. It's so good.
That's how you're choosing it, man. You're choosing it.
That's like a double finger shirt. Come back next week.
Okay, ready for the next one? Good. Everybody got it down? You guys on the other side, can you guys hear me? Is anybody there? Okay. Good.
Well, that's the first time I did
That's
that.
what I was doing.
Out loud, that's the first time you said.
Fish.
I guess that's.
Okay.
Fish and special.
Oh. We talked about
Same
isomers,
on it.
right? So what was the definition of an isomer again? That's right. Same chemical formula, but different structures. We also have what we call geometric isomers. Same chemical formula. Their structures are slightly different. The difference is how their geometry is, right? And so where the kinks are going to be at. Okay. So what do I mean by that? So when we talk about isomers, geometric isomers, we're going to make reference to cis and trans. Cis are going to mean they're on the same side. Trans means that they're across from each other. Okay, so if you guys take a look here, this first one is an example of a cis. So you have your double bond and you have carbons on the same side. In the trans, we have our double bond, we have a carbon here, and then we have a carbon across. Okay. So this is an example of geometric isomers. Okay, now this here This first one is an example of an isomer, but it's different because where the location of the double bonds are. They behave differently, right? They're going to have different chemical properties. So here you can see that the one butene, it melts at minus 185.4 degrees Celsius, and it boils at negative 6.3 degrees Celsius. Compare that to our cis, which is minus 138.9 degrees Celsius, and then it boils at 3.7 degrees Celsius, and that's different than the trans. Okay, so because how they're organized, they're going to behave differently. Those geometries, even though they have exactly the same chemical formula, all three cases. Okay, you guys with me? And so that's why it's important to understand those shapes. Remember, we're talking about the shapes and where things are located and all that stuff, because that plays a part in things. So, looking at the structure, why do you think the cis has a higher boiling point and melting point than the others? At least boiling point. I said, looking at the structures, why do you think cis has a higher boiling point than others? Because they're all on the same side. Okay.
More close packed. Less spread out.
Yeah. So it's, you said symmetrical because they have symmetry associated. So technically, they all of these guys have symmetry. They're going to be associated with them, technically.
It's because they're on top.
Because they're on top.
Because maybe the trans has a positive. And they're all symmetrical.
So what's happening at boiling point?
Yeah,
No, what is happening at the boiling point? What's the transition that we're going through? Was that? It's
Oh,
going through a physical
they're
change.
breaking apart, becoming something new.
It's not that they're breaking apart, but they're going to be able to break apart from each other, right? So why do you think that these guys, because the boiling point is higher than the others? So in other words, when it's in this liquid state, to get from a liquid to a gas, it takes more energy for it to get from a liquid to a gas. What do you think is happening to cause that? Now they have the same number of carbons, so we know it's not the length of the carbon.
Stronger bond.
Is it stronger bond? But they all have the same type of bond. What was that?
What's this on the press exam? Somewhat similar,
There was something that was very similar to the gas.
right?
Yeah.
So that's what I'm trying to remember. Just this stuff. Isomer bonds.
In this case, it's not bonds, but it's going to be what we call intermolecular forces, right? So they have the same number of intermolecular forces, but you have more exposure in one case than you would have in the other cases, right? By how they're organized and how they're going to be able to interact with each other. So because they have more opportunities, because that openness that it has, since they're both in the, openness, that you have more opportunity for it to interact. Where you have the ones that's trans, which can also interfere with interaction. And so that's one of the things that we have to pay attention to, that organization of the structure. Okay, so that little V shape. So guess what? We can interact here. We can have interactions here. We can have interactions here. This one is a lot harder to get those interactions because they will block other things. This gives us more surface area. Okay. Okay, our next one. It's the last one. So these are carboxylic acid and esters. Okay, so I'm going to do that on the board as well. You guys don't mind. So in the case of carboxylic acid, a 6-carbon chain. Okay, in this case, we're going to put oic acid. Then so in this case, so this side here, it's going to get the longest chain, or it's going to get the chain name, and then you're going to put YL. So yeah, 1, 2, 3, 4, 5, 6. So, and then this guy that's attached to the O over here is going to be 8. So we're going to have 1, 2, 3. From oh, sorry. Oh. Okay. Okay, so if I have so, how many carbons? that would be. Side.
6.
X. That was 8. Any times. Otherwise, I would. And is that 8? You add it up. And if we do this. Cards. And then it comes off. Perfect. Okay. Card it's. Questions? Are you guys dead yet? Yeah, we got 2 more major things to talk about. Then I can. Okay, guys, ready for the last ones? Yeah, let's do them. Okay. So the last ones are a me and Emma. So let's cut this down. Okay, so my last. So means are going to be derivatives of a moment, okay? It's a mean, okay? What is the chemical structure of ammonia? Okay, so a primary amine means that you have 1 hydrocarbon. So we'll have an R representing our hydrocarbon on only 1 of them. That would be considered a primary amine. A secondary amine. Right. Secondary means that we have 2 hydrocarbons, our prime, and then we have tertiary amine. Means that we have 3 hydrocarbons. attached to it. The R represents the nitrogen levels. So let me give you guys examples. So if I have so the way that we would name this guy, longest chain. Chain 1, 2, 3. Call this guy. Rope. Example of this. So that would be example of a primary. Example of a secondary. Okay. And then the other one is. Okay, so does the M come first? There's no source. The M come first, so the that comes first. So we call this one that.
Something cool. That was
So they all met. So since we met, we can say. Since there's three met, we can say try. Try methyl. So the last example is amine. Okay, so for amines, okay, so you got to count them on the carbon chain. Six carbons. So prefixes. All single bonds. So we're going to end it with amine. Okay. Location. Well, it's 5 chains. 5 and 4. So 5, 4. 4, 5. Sorry. And they're what? Okay, so these guys are sort of the foundation of something else that we read. that hydrolyzed.
What is the name of the R? Is the R change everything?
The R is just representing hydrocarbon. So here, this here, means this amine, so it could be any hydrocarbon, carbon chain, right? So any hydrocarbon that goes in, that falls into the sample, this is the functional group. O, double bond into the carbon, attached to the nitrogen. We know that that is always going to be amine. Carbon attached to nitrogens, you know that that's going to be.
Why are we using an R instead
An R could represent any hydrocarbon. So instead of putting C, and we want it to represent any hydrocarbon in your classification. So it's a generic term for any hydrocarbon.
of? So like, you're showing us a sample?
Exactly.
Okay.
So R is the generic way it's. Good question. Okay. Doesn't work. Okay, I have one more thing to talk to you guys about, then I'll let you guys go. Last one is amino acids. You guys know what amino acids. Can I erase? Everybody got this?
Yes.
What did I miss?
Oh, I just said I know there.
Oh. Okay, so this is the generic form of an amino acid. Right? And the R can represent any hydrocarbon. And so this is where you're changing your amino acid. And so if you take a look at it, this is functional group look familiar. Yes. Yeah. What is it?
A carbonyl group.
Acid. And then we just use this one here. That's one. Or that's it's okay. So the name. That's pretty neat. Okay, so if you take a look, there's a summary. Those are all of them that we've gone over. I've gone over most of them. There are more. There are more functional groups, but these are the main ones that you guys are going to encounter, either in your body or on your soap bottles or some bed. You know, so I tried to give you some background, or you're drinking it at the bottom, right? So I tried to give you guys some background to all of these. Now, Monday, we will have a lecture. Okay, so you guys are going to get your last lecture. It's gonna be a nice lecture. So you guys go over those notes. It's gonna be a lot of stuff. That's our very last lecture. In 3 weeks. So. Monday, and then on Wednesday, we were taking a trip. So you guys have to be at 7 a.m. in the morning. 7 a.m. in the morning. 7 a.m. in the morning. You sure it was late?
No, trust me. The whole thing that they said, yeah, no, all right.
But I don't know if you go to the road, I can't go.
Well, I guess I'll see.
I'm gonna try to make this sound as my favorite. It's my favorite thing to be the cruise. I'm trying to have it. I pay bills, bro. Keep my bills.
And
I do, but it's, I don't think I have, it's similar to like, a franchise, like you really say it's a big.
make sure you're there. I have 2 people who currently live. 3 people that live.
That's good.
Let's go to the game.
She did.
No, she gets like a.
Show me.
He said no.
That's what
You say,
it's not you had it too, bro.
Everybody's done. I won't say who got what, but I will put the top 3 because of the picture.
Did we show?
I never like it should.
Russ, I don't know about 92, bro. What the heck? Asking my answer.
Yeah, we gotta remember it's all my classes.
Oh.
So I used to.
I'm not saying anything. I didn't say, you guys are making assumptions. I have not said one word.
You're trying.
I didn't show my.
You're trying.
I didn't know how to.
You guys have a good night, and I will see you guys Monday.
Maybe.
Monday.
Maybe.
And you also have your project that's gonna be due, right?